So now that we can walk around and we can shoot all we like, we have the basics of a twin stick shooter. But these bullets are just going to fly through walls, and if we were to make enemies, they're just going to fly through enemies, because we don't really have any programming to tell them what to do when they collide with something. They have a collision that's set to overlapping things, but they aren't being told what to do when that overlap actually happens. So let's take a look at that. On a normal blueprint, you might be used to having a begin overlap event. And that is very nice, and we're going to do something similar to that in C++. So what we're going to do here is I'm going to open up the base bullet class, because that's the thing that's going to be colliding or overlapping with all things. And I also have a other class open here because the overlap function that we're going to use does have quite a few parameters, and I don't want to mess them up. So I'm just going to copy over from my own game where I have a class that also has a begin overlap function. It's very important that your overlap function has these exact parameters, because we're going to bind it to a delegate, which we'll explain more detail a little later maybe. And when binding to certain delegates, you do need to make sure that the things you bind to it match it in terms of these parameters. Even if you don't plan on using all of them, you do need to have all of them. So what are all of these? Well, the primitive component is the overlapped component. So that is the component on this actor that's getting overlapped. Other actor is pretty self-explanatory. That's a pointer to the actor that you are overlapping with. The other component is the component on the other actor that you are overlapping with. The other body index I have never used, so frankly, I'm not entirely sure. And then we have a bool and a hit result for sweeping, and that has to do with... Sweeping is more or less checking one frame ahead whether or not something is going to collide, instead of checking whether or not it is colliding. So if this overlap happens as a result from a sweep and not from an actual direct collision, this will be true, and the hit results from that sweep will be stored in this variable or this parameter here. Now that we have that, let's make the definition for it, and we can start coding that in a moment. But this won't automatically do anything, because we're never running this, and it's not like just calling it begin overlap is going to run it when you overlap with something. It's not that smart. We're going to need to bind this to a delegate, as I alluded to before, and we'll do that at begin play. So how do we do that? Well, we already have a collision sphere, a sphere component here that is set to overlapping. So if we just get that collision sphere and we say on component begin overlap, we can add dynamic. And there we pass in a object, which is going to be this, and then we pass in the address of a function that matches this signature, which is the overlap component, other actor, other component, and so on and so forth, the thing we just went over. And if you pass that in, now whenever something overlaps with this component, this function is going to run, and all of these parameters are going to get filled in with the relevant information. And that is, in a nutshell, also how delegates work. We'll get a bit more into delegates and making your own delegates and stuff like that in a future video pretty soon, because it's very useful stuff to actually use. Today we're not going to play around with delegates too much. I do want to show you something that is almost equally as useful and is a little easier to understand and wrap your head around as a secondary objective in this video. Oh, and it is important to also mark whatever function you are binding there as a U function. Because when we overlap, what are we going to do? Well, first and foremost, we're going to destroy this. We're just going to destroy the thing itself. But we also want to do a number of different other things, and that is we want to spawn a new particle system, and we want to, if it is a character that we are colliding with, we want to actually damage that character. Now the damaging we're going to leave for the next time, because I want to really dive a little bit more into it, due to the fact that Unreal has a built-in damage system where you can send a deal damage to an actor, and then that actor will run its receive damage function, and then you put all that information in there as to how that damage should be calculated, rather than calculating that all over here and just subtracting a number on a different actor. It's a very good system. It's a little much to get into today as well. But maybe you want to have some bullets that do special stuff, right? Maybe you want to have some bullets that when they impact, they spawn 3 new bullets that fly off in random directions. Maybe you want to have a bullet that when it hits, it creates an area of effect damage thing. Whatever we want to make a function that we can put different kinds of things in depending on the kind of bullet that we're using. And that's what we're going to get into right now, because we're going to be talking about virtual override methods. You've seen me talk about this a little bit before and kind of dodge around it because I wanted to explain it in a more proper context, and that's what we're going to be doing here. So in our protected section, we're going to be making a new function here, which we will first mark as a virtual. That will be a void, and we'll say it's called bullet hits. And you do want to spell virtual correctly. So what does virtual mean? Virtual means that this function can be overridden by child classes of this class. So let's use the tick function as an example, because this is a virtual function, meaning that if I make a child of my base bullet, which maybe, again, we want to make an area of effect bullet, so we would make a child class of this one, and then I could override whatever is in this tick function. So in this case, the bullet hit function itself on this class is going to be entirely empty. But if I make a child class that does make use of it, I can override the bullet hit, and suddenly it will do whatever I put into that function, because this base bullet says, just run the bullet hit function, and whatever is in it, we're just going to run, and we can actually fill that in on a child by child basis, which is really, really powerful. The override keyword at the end here is just something for you as a programmer to keep track of. Hey, oh yeah, this is an override method. It's not actually needed. It's just something that checks, hey, this function, does that A, even exist on the parent class to begin with? And B, more importantly, is it virtual or not? Because if it's not marked as virtual, you can't override it. So let's make a definition for it, because you do need to do that. And then whenever we overlap with something, we're going to run the bullet hit function, which again, in this class itself is going to be entirely empty, but we can make child classes of this, which will still run this function, but if it's overridden, it will do something different, whatever we put into it. And in a function that is an override function, like we have seen before, you will see that it can start with this super tick in this case. And that is just saying the function that exists with this name and these parameters on the parent class, which there exists a tick function on the parent class of base bullet, because that's just actor, run that first and then run whatever code I put in here. Or you can also run it at the very end if you wanted to. If you don't put this super tick in there, like I don't have that in my own class because I don't have anything in the parent function, but say you do have some functionality in the parent function that you don't want to run in the child version, you simply just don't include the super here, and it won't run whatever is in the parent function. And as an example from my own game here, I'll show you a little bit of code. That's the class that I took the begin overlap from as well. But here I also have a virtual void method called special attack. And you will see that special attack in this class doesn't have anything in it. And that is for the base weapon class. So I just make a class for the base weapon. That's not actually going to get implemented into any blueprints. But then all my other weapons are children of that. So if I go into my sword class here, you can see it's a child of the weapon class, and it has a override for the special attack. And here I actually do have a bunch of code. And this way my character just has a reference to a weapon, and whenever I do the special attack, all the character needs to know is just tell my weapon to do the special attack, and then based on what weapon I am wielding at that given time, it will execute the corresponding code to that specific weapon. Now, let's also make a U property edit defaults only for a U Niagara system, which is distinctly different from a U Niagara component that we've used somewhere before here. Here, that's a component, which means that it's going to get built as a default subobject in the constructor, and is going to be a component on this actor. This is just a Niagara system pointer, which is going to point to a Niagara system that we can then spawn in as a separate actor through some different code. So this is not going to be a component on this actor at all. This is just something that can hold the type of emitter that we want to spawn in whenever we overlap with something, which will be an entirely different actor, which is important because when we overlap with something, very soon after that, we're going to destroy ourselves. So we spawn in a separate actor to do some particle stuff. And that's going to need to be forward declared, actually. And we'll call that impacts particles. And we will need the include for Niagara system.h in our CPP file. And that's not the only include that we need, because we also need to include the Niagara function library, since we need to have a way to spawn in that system as a separate actor. So that is the include Niagara function library. And now in our begin overlap again, we will say U Niagara function library, and then we will spawn system at location. And for that we will need our world context object, which is going to be this as always. Then the Niagara system, which will be our impact particles. Then we need the location, which is just going to be our get actor location, which is going to spawn it in at the exact same place that we are at right now. The rotation by default is set to F rotator 0 rotator. The scale is just going to be 1. Auto destroy is automatically true. Auto activate is automatically true. And that's really all we care about. So we don't even need to put in any of the other parameters, because a lot of these parameters have default values. And when they have default values, we can just skip them altogether, which is great. So right now we have on our begin overlap, we are spawning a system at our location. We run the bullet hit function, which isn't doing anything right now, but it will give us the ability to do things in the future, which is really nice. And then we destroy this object. That's my bad. You don't actually need to put in a thing to destroy in the parameters here, because it will just destroy whatever object this is being run on. So if we had a different object like other actor, if we wanted to destroy the other actor, we would do it like this instead. If you don't put anything into the parameters, it will just destroy itself anyway. So I made a little mistake, but I hope that that's not too confusing. And now in our simple bullet, we have the impact particle variable here. I just made a simple impact particle system, and let's see if it works. And this map might not be the best example here, because you do seem to need to have generate overlap events on the target on as well. By and large, that's not that big a deal, but you'll see I just enabled it for this pillar. This pillar, they just go straight through, and this pillar, they will explode up against. And it does seem like they are looping. Actually, we don't want them to loop. That's an issue with the particle system itself. I've set it set to loop infinitely. It should only loop once. And there we go. We have shooting, and we can interact with things. That's all very, very cool. So that is how you set up basic collision related things in C++. Again, do be aware that in order for that to work, you do need to have set generate overlap events on whatever you are going to be overlapping with, it seems like, which is highly annoying, but it does make sense. Like this character has it set to on by default, so if we put in another one of these characters over here, we can shoot this, and that should do the trick. And of course it doesn't have any AI because we didn't program any AI, but you can see this way we can shoot at the enemies. And you probably want to also, the walls of like your dungeon or whatever you're making, probably want to also set them to have overlap events enabled, because that way these bullets won't go through the wall. And the reason that is relevant is because these bullets, if I press F8, I will be able to highlight one of the bullets that just flew off into nothingness, is all the way over there, and that's not going to despawn. And if you play for like half an hour, there's going to be thousands of these things just flying out into nothingness and taking up a whole bunch of your memory. So you don't want that. You do want them to kill themselves after a certain time. So if you just make sure that all the walls will generate overlap events, it will just kill itself when it runs into a wall. It's also not a bad idea to just put in a timer in the bullet itself to just say, after 30 seconds, just like despawn yourself. Just kill yourself after 30 seconds. You're not going to be relevant anymore anyway. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thanks to my Cave Digger tier Patreons, Sir J. Thomas,